Jim McGregor here with Samir, who is the CEO of MIPS, and we're at Embedded World 2025, and excited. You announced the 8500. You're talking about the Alice Explorer toolset and how you can use it not just for analyzing performance, for like a motor control, but actually understanding if it's worth using custom instructions, which is the value of the MIPS architecture. Now, so excited to see all this happening. You first announced you're going with RISC-V last year, and things seem to be rolling now. And we met at CES, and I made the comment that I never thought I would see another. There will never be another pure IP semiconductor company in this industry again. And you agreed with me.
Yes.
So
I think I said there will never be another successful semiconductor IP company.
And so why don't we talk about your strategy and how you've expanded that beyond what just MIPS used to be in selling cores to really being kind of a full service solution company?
Yeah. So thank you for covering us, right? So look, IP is at the core of semiconductors, right? Without differentiated good IP, a lot of the growth which we are seeing around and the value creation would not happen. So when we say there will not be another pure play IP company, it's not a comment on the nature of needing IP. I think IP is needed.
Yes.
What's happened is, I think, at least my interpretation is that the customers have moved away from wanting to license and be reliant on licensing CPU IP. And that's a combination of the advent of RISC-V as an open source. So the entire reason to do RISC-V is to not be bestowed upon a single vendor and be able to do your own. It's the Linuxification of hardware, as I like to call it. So very similar to moving from the Microsoft era to the Linux era, this is getting open. And secondly, if you look at the commercials around any licensing long term, if you're aiming to be a winner in the market, it turns out to be cheaper to just develop that IP long term versus licensing it. Now, there will be certain cores which are very high end, which will always probably still have a licensing market. But there you're competing with the incumbent, which is ARM, and I think it takes time for the RISC-V ecosystem to mature to a level where customers will have the confidence to move to that. So I think there is a space in the IP space at the highest end where licensing works, and that's where we will focus as well. But most of the low to mid end and even high performance MCU space, I think customers are looking for more than the core. I think they're looking for subsystems because these cores don't work independently anymore, right? They work in very close interaction with the accelerators, with the analog peripherals, mixed signal. So I think customers are looking for us to be able to deliver and guarantee performance. So in our case, for example, the 8500 is all about motor control. So rather than saying Raven is a very differentiated core, the core which we're developing, but the core enables a very, very reliable, high performance control loop. So instead of talking about the core and the spec int and DMIPS and core mark, those are important, but those are not sufficient. We're talking about how we deliver control loop performance. And I think that's more important for the customers because their application is not core mark, their application is control loop. And I think the change here is historically IP providers have provided CPUs and left everything else to the customer. I think the customers are moving up the value chain where they're starting to focus on higher level software, integration systems. So us in the IP domain have to also kind of step up and provide more than just the CPU.
Well, and I think there's been a challenge, obviously, with Moore's law slowing down. Anybody from embedded systems all the way through data centers is looking for a way to optimize. A data center, it may be about, how do I get improve my TCO and get a higher ROI. At the low end, it may be, how do I improve battery life? How do I improve performance? And, I may not get that from a standard core or standard IP.
Yeah, absolutely right. I mean, we at MIPS are all about application specific. We've been saying that since we kind of rebranded and that. And I mean, yeah, because see, silicon is getting in some ways more expensive, right, to do. So the last thing you want to do is spend $150 million building a very complex SoC and not take the extra little bit of R&D to go make sure that the CPU has application-specific personalities. And I think that's key. It still needs a lot of standard features, but I don't think so. We sit down and develop CPUs inside MIPS with no application in mind. It just doesn't work because you're trying to figure out, okay, this is what we're trying to go solve. And it's not typically one application. It's not like, okay, here, it's a problem. Like we want this to be, like inside MIPS, we like to call it real fast and real quick. So there's real quick on the application side and then real fast, which is on the latency side. So I think it's trying to understand what we're trying to do. Even when we're defining the next generation products, right? There's a healthy debate inside, like, should we go chase clock speed and chase host performance, or are there more application-specific functions which we should chase and move data around more effectively? Can't do everything, but take a personality, take a lane, and try and do a good job of that.
Well, and that's not an easy job. I mean, when you just think of like one market like healthcare, it's 1,000 different applications.
Yeah.
So, I mean, it's a challenge. I think.
And I don't think MIPS needs to be in every application, right? I mean, one of the funnest part of the job is it's easier to decide what to do than to decide what not to do. So my motto and the team's motto has been, let's first decide what we're not doing. Like, I have no qualms saying we're not chasing smartphones or PCs or honestly anything with a screen. Why? We don't have a plan to port Android yet. Maybe out in future we'll think about it. We don't think our architecture does anything spectacularly different versus ARM. If anything, ARM is the best architecture when it comes to the screen. So if you're working on something which is low power and screen, I would go with ARM, in my opinion. And but if you, where we look for things is where it is more data processing, more latency, headless stuff, and I think that's where we focus. So sort of having that clarity in the team takes 50% of the angst away, saying we're not doing that, we're doing this. Now within this, what is the ascending TAM and what is the interesting application? Let's go chase that.
And most of the applications are not going to require those higher level operating systems that add additional latency and overhead.
So operating systems are starting to get pretty mainstream, right?
Yeah.
One of the original things which MIPS did was it always had an architecture which allowed you to have multiple operating systems at the same time. Not only the M8500, if you go back to the M5500, which was the old MIPS legacy microcontroller, that supported virtualization. I mean, it was ahead of its time at that time. Today, it's pretty normal. But I think with the MIPS architecture, we're going to be able to go support standard operating systems at really, really low cost points. So even better than what ARM does today.
So it doesn't matter. It doesn't have to be a real-time operating system. It could be a higher level operating system.
It could be a higher level operating system as well. The high level operating system tends to add more system cost than chip cost because now you have a DDR and all of that. But we'll leave the choice to the SoC developers versus we won't limit the cores.
Well, I know that you're not going to be able to announce anything here at the show, but I would imagine this first step into application-specific product is going to lead you down probably 100 more potential avenues.
Yeah, Jim, I mean, look, we named it Atlas, right? And this is James's handiwork. It's a very nice name. Atlas does not have one country or one state. Atlas has many countries and many states. And it kind of gives you a map on how you go. So I think we are fundamentally committed to the real-time market, the automotive market, the industrial market, the robotics market. And I think we aspire to be a full solution provider in that, which would mean we will have real-time cores and MCUs, which we just announced. We announced an application subsystem around embedded AI. So there will be that, which will manifest itself very similar to what you've seen as an application subsystem, but also an example silicon. And we already have some cores, which we've announced, and like the Mobileye Core 8700. We have the Shogun core, which is Shogun is the internal name, but 8500. So we have that as well. So I think we will continue building on this. But honestly, we like building CPUs, but we've also got to start balancing ourselves and building some subsystems so that we know what problems we're solving and giving a little bit of a software stack on top as well.
Is hiring enough people an issue at this time? Because obviously, the more interactions you have with customers, sometimes the more staff you're going to need.
Yeah. So look, R&D. We believe in platforming
Yeah.
on how we develop R&D, because otherwise we will definitely go out of business. So we sort of stay to the same basic core, and then we go out and branch.
Okay.
And I think we've been able to hire talent. It started off slow, like 18 months back, when we weren't clear about what we were doing exactly, and candidates would not kind of see it. Today it's much easier, right? And I think we will continue expanding. I think there is a need to bring in more embedded AI talent. There's not a lot of it available, so I think that's always going to be something which we will continue working on. But no, I think keeping ourselves grounded on the fundamentals of how we develop foundational technology, and then how do we go expand that foundational technology in terms of what we deliver to the customer, is pretty fundamental.
And you're going to be one of the experts in RISC-V, which is, really just in the beginning.
Yeah, RISC-V, look, we need the RISC-V ecosystem to continue flourishing.
Yeah.
And we fully intend to put back in the ecosystem, upstream what we're doing. We've the 8700, the application core, we already have Linux patches being upstream. So I think we've got to give the developer community the confidence that we are mainstream on that. We're not a side embedded core doing non-customer programmable things. I think we're pretty mainstream on that. It's going to take time, right? So we've got to be realistic. I think the RISC-V space on the MCU side, the high performance MCU side, the embedded space, I think we're there, right? We have Green Hills has made an announcement. Infineon's jumped in with the entire family, so that's awesome. I think the days of proprietary architectures are done. I said so yesterday that anyone living under a rock is probably looking at proprietary architectures right now. But if you're not living under that rock, then you're probably looking at RISC-V. And if you are living under the rock, get out, otherwise the rock's going to fall on you.
Yep, I would agree. Well, thank you very much.
No, thank you. Appreciate it.